Hey, fifth grade. Welcome back. Lesson 78 today, squares and exponents. Alright, so I'm going to start with the exponents, and this is a little bit of a review, but also a little bit new, so I want you to really focus in on what we're doing here. So exponents are used for repeated multiplication. So what that means is if I have something like 4 to the 4th power, or let's do 5th power so we don't have the same number. 4 to the 5th power, that means I'm saying 4 times 4 times 4 times 4 times 4. We're repeating the same multiplication. And so we can use a little exponent because the same number is being used and it's just being done over and over and over again. Now the base is the number that is repeated. So in 4 to the 5th power, which one's the base? Hopefully you said 4, because 4 is the number that is repeated all the time. So that's considered the base. So this number here, that 4, is the base. The power is the base and the exponent. The exponent tells me how many times it's repeated, right? So this is the exponent, this is the base, and the power is both combined. Now when we say numbers that are exponents, we want to think of them like this. So we say 10 to the 1st power, okay? Usually we rarely use that 1st power because it's just 10, right? We're only multiplying 10 and it's 10. So 10 to the 2nd power, we have 10 times 10, but we also call this 10 squared. We call this 10 squared. This is what it sounds like, 10 squared. And we call it 10 squared because that's exactly what it is. It's a square. If I had 10 squared, that means I have a 10 by 10 situation, and they're all 10s over here then. 10 squared, and that means that I have a square that's made up of 10 pieces by 10 pieces, right? 1, 2, 3, 4, 5, 6. Okay, we're not going to even continue trying to make 10 by 10. It's going to be too big. But anyway, we would get, if we did that and we had 10 by 10s, that would be 100, right? Because it's 10 times 10. On to the next one, 10 with the 3 there. We call this one, I'll put it out here, we call this one 10 cubed. 10 cubed, okay? Because 10 cubed, this is a flat piece, right? It's in a two-dimensional plane, so it's two sides. One side here, one side here, 10 by 10. This square that we have here is going to have depth to it. It's going to have 3 sides that we look at. Okay, so we have this cube, and that's exactly what it is a cube. So this one would say that it's 10 going across, it's 10 going up, and it's 10 going back. So it's cubed, 10 by 10 by 10, and it makes a cube. So that's why we call it cubed, because that's exactly what it does. It makes a cube. This makes a square, this makes a cube. So 10 to the 2nd power we call 10 squared, 10 to the 3rd power we call 10 cubed. And as you've noticed, I've said, 10 to the 2nd power, 10 to the 3rd power. We want to use the terms 10 squared, 10 cubed. Then when we get out of that, that grouping, then we start to say to the power, to the blank power. So if I have 10 here, I say 10 to the 4th power. 10 to the 4th power. You see the number that is your base number to the, and then whatever your exponent is, and that's it's said like you were talking about what place in a race you came into. I came in 4th place, so 4th power. 10, my base number, to the 4th power. So if you had to write that out in words, you'd say 10 to the 4th power. If you had this number here, we would say it's 3 cubed because we have that 3 there. If I had this number up here, we'd say it's 4 to the 5th power. 4 to the 5th power. All right. When you're trying to figure out the answer to these type of things, we can look at it. Let's just kind of rearrange this here. So you know that it's 10 squared, 10 cubed, 10 to the 4th power. Well, let's see what those actually equal. Okay, set n squared equals what? Okay, so if I had 10 squared, that's the same as 10 times 10. If I had 10 cubed, that's the same as 10 times 10 times 10. 10 to the 4th is the same as 10 times 10 times 10 times 10. All right, so if we look at the answers to these, well, we know 10 times 10 is 100. And then what we have here is we have 100 times 10. 100 times 10, we have 1 times 1 is 1, and then we have 3 zeros added on, right? 1, 2, 3 zeros, and do the 1 times 1 times 1. Then over here we have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, and we have 1 times 1 times 1 times 1, so that's 1. And we get 10,000. All right? Now, I want you to think about this. Think about our place values. So, all right. So let's say this is going to be the ones column. The ones column would be 10 to the 0 power. Then the tens column is like having 10 to the 1st power, because 10 times 1 is 10, and that's exactly what we get here. We get a 10. If I had 10 cubed, 10 cubed would actually be 100, and that's where I'm at. I'm in the hundredths column. And if I had, there's squared, I think I said cubed, I meant squared. 10 squared is 100. 10 cubed then, 10 times 10 times 10, we get that 1,000, and that's where we are here. We're in the 1,000 column. See, so we can actually figure out the 10 to the nth power, whatever power that might be, by looking at place values and just going out that many out. So I have that 0. I have that 0 in the ones column, and then the tens, just one less, or I mean one more than what I have. 1, 2, 3, 4 columns, right? 4 columns for that 10, but I'm actually the 3rd power. You can also think of this as the amount of zeros that come after that 1. Only for tens this works, of course. So if I have 10 squared, that means I have 2 zeros over here and I have the 1 in front. If I have the 3 here, that means I have 3 zeros and the 1 in front. Right? So let me see if you can figure this one out. All right, if I have 10 to the 9th power, what's that going to equal? No multiplication. Can't do multiplication. Just tell me what it is. If it's 10 to the 9th power, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros and the number 1. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So when we look at that one, we have, here's the thousands, here's the millions, here's the billions. So 1 billion. And that's how that goes. When you're doing the tens, you can use that shortcut. Well, let's go back up here. 3 to the 3rd power. 3 to the 3rd power means that my big number is 3, and this is how many times I have that 3. 3 times 3 times 3. It's not 9, okay? We have to do 3 times 3 is 9. 9 times 3 is 27. And that's where we get our answer for that. If 2n equals 6, what is n squared? Well, first I have to figure out what n is. 2 times what equals 6? Hopefully you said 3. Okay. If that's 3, that means n equals 3. So if I put the number 3 there in place of the number or letter n, and I put the 2 up there for the squared, 3 squared, remember the 3 is the number I'm writing down. How many times am I writing down that 3? 2 times. So I have 3 times 3, which equals 9. So I have 3 times 3 equals 9, so n squared equals 9. All right. The idea of a square root. Now we talked about square roots last year, and we talked about square roots this year already too. When you think of a square root, basically what we want to think about is just that idea of a square. A square. So if I'm looking for the square root of 36, I have a square, and the area inside that square is going to be 36. And because it's a square, it has to either be 1 times 1, a 2 by 2, a 3 by 3, a 4 by 4, whatever numbers that you come up with. It always has to be the same number on one side as it is on the other, because that's what makes it a square. If we have 4 on this side, then we have 4 on this side. So here, what times what is 36? The same number. We get the number 6, right? 6 times 6 makes it 36. So my square root of 36 would be 6. And when you look at a perfect square has no decimal in it. It has no fraction piece. It's just a perfect square. And that's all the ones that we see on a diagonal on a multiplication table. So if I had a multiplication table, I would have 1 times 1, 2 times 2, 3 times 3, and they all go on that diagonal, and you can find those. And I think the chart that you have actually has them shaded in. Now I want to talk about number 7, example 7 on 507. Okay, it gives you this 9 plus 16, the square root of 9 plus 16, greater than, less than, or equal to the square root of 9 plus the square root of 16. All right. Now, in math, there are some rules here. When these are separated, when they're two separate square roots, we need to find the square root of each number separately. So I find the square root of this one. I find the square root of this one. So the square root of 9 is going to give me 3, plus the square root of 16 gives me 4, because 3 times 3 is 9, 4 times 4 is 16. On this side, when they are under the same square root sign, you're going to go ahead and add those together first. So 9 and 16 gives you 25. So what you have here is you have the square root of 25 is greater than, less than, or equal to 3 plus 4. Well, now I can do 3 plus 4, and that's going to be 7. And now I look for the square root of 25. What times what equals 25? Answer that being 5. So you have 5 is less than 7. And remember, the Pac-Man is eating the bigger numbers, or the alligator, or whatever you want to call it. He's chomping down. Oops, I did my picture wrong. Haven't done that wrong in a long time. All right, so we have the greater than sign. There's his eye, and he's eating the bigger number. So off he goes to the bigger number. 5 is less than 7. Again, 9 plus 16, you do that first. We get a 25. It's still a square root. We haven't found the square root yet. All we've done was added it together. Over here, 2 individual pieces, so we're going to find the square root of this one, the square root of that one, then add them together. All right, as you see, it gives you 2 separate answers. All right, your lesson is done for today, and you have your worksheet to do.